Welcome to Channel Academy, and this video is a continuation of our basic mathematics. So if you've not watched the previous one, please do well to go and watch, as this is a continuation. So by the end of the class, you should be able to solve questions like this. Find the reciprocal of 2 over 3 all over 1 over 2 plus 1 over 3. And then question also like, which of the following number is a perfect cube? A, 350, B, 504, C, 950, D, 1728. So by the end of the class, you'll be able to solve these questions. Alright, let's move on. Alright, the first we'll be talking about is square of a number. What is the square of a number? The square of a number is a number multiplying itself. So let's take example. The square of 2 can be written as 2 raised to the power of 2, which is the same thing as 2 multiply 2, and the result is 4. So if you say the square of 5, same thing as 5 raised to the power of 2, which is equal to 5 multiply by 5, and the result is 25. So that is the square of a number. So any number you say the square of, it is always raised to the power of 2. Say the square of x is x raised to the power of 2, which is same thing as x multiplied by x. Now note, x multiplied by x is not the same thing as 2x. So put that in mind, as x raised to the power of 2 is same thing as x multiplied by x, but it is not the same as 2x. Alright, the next we'll be talking about is cube of a number. Cube of a number is a number multiplying itself twice. Like in our previous example, when we say square of a number, it was multiplying itself just once, but in the cube it's multiplying itself twice. So let's say the number is 2, so it multiplies itself 1 and then 2. So that's what the cube of a number is, and it's represented as 2 raised to the power of 3, which can be equal to 2 multiplied by 2 multiplied by 2, and the result will be 8. So 2 multiplied by 2 is 4, and 4 multiplied by 2 is 8. So if we take another example, say the cube of 5, which can be represented as 5 raised to the power of 3, which is equal to 5 multiplied by 5 multiplied by 5, and the result is 125. And then if we take another example as x cube, the same thing as x multiplied by x multiplied by x. Remember, x is not equal to 3x. It's not equal to, so it's just x cube is same thing as x multiplied by x multiplied by x. Alright, having said that, let's move on. The square root of a number. The square root of a number x is a if a multiplied by a is equal to x. So if the square root of a number x is a if a multiplied by a is equal to x. Let's take example, the square root of 25. It can be written as 25. The square root of 25 is equal to 5, and that is because 5 multiplied by 5 is equal to 25. So that is what the square root is saying. Alright, let's take another example. Let's say the square root of 16. What would the result be? So the result will be 4. And that is because 4 multiplied by 4, the result is 16. Alright, so let's move on to the next. Cube root. The cube root of a number x is a. If a multiplied by a multiplied by a is equal to x. So let's take an example. 8. So the cube root of 8 is equal to 2, because 2 multiplied by 2 multiplied by 2, the result is 8. And then if we take the cube root of 125, the result will be 5. And that is because 5 multiplied by 5 multiplied by 5 is equal to 125. So that is cube root. Alright, let's move on. Reciprocal. This is the inverse of a number. Let's give an example. If we have 3 over 7, the reciprocal will be equal to the inverse, so it becomes 7 over 3. If you've watched our fraction, the video we talked about fraction, we said the up value, the numerator, and the down value is the denominator. So in reciprocal, the numerator becomes the denominator and the denominator becomes the numerator. So that's for reciprocal. So if we have a number like 5, the reciprocal of 5 is equal to 1 over 5. And that is because 5 is same thing as 5 over 1. So every integer is actually being divided by 1, because any number that is divided by 1 remains that number. So that's why the reciprocal of 5 is 1 over 5. Alright, let's move on. The next one is perfect square. These are factors that can be expressed as even power. If you've not watched our previous video, please do to go and watch, because we talked about factors in those videos. So we won't be going back to factors. We'll just talk about perfect square. So like we said, perfect square, these are factors that can be expressed as even power. So let's give an example. What are the factors of 12? So factors of 12, we use the long division method. 12. If 2 divides 12, we have 6. 2 can still divide. If 2 divides 6, we have 3. 2 can no longer divide, so we use 3. If 3 divides 6, the answer is 1. So the factors of 12 are 2 multiplied by 2 multiplied by 3, which is the same thing as 2 raised to the power of 2 multiplied by 3. So between 2 raised to the power of 2 and 3, you can see that 2 is expressed as an even power, which is 2. Therefore, 2 raised to the power of 2 is our perfect square, while 3 is actually being raised to the power of 1. 3 is raised to the power of 1. Alright, so let's move on to the next. Perfect cube. These are factors that their power are multiples of 3. Let's take an example to explain this. Let's find the factors of 72. Okay, let's use the long division. 72. If 2 divides 72, the answer is 36. And if 2 divides 36, the answer is 18. 2 can still divide 18. If 2 divides 18, the answer is 9. 2 can no longer divide 9, so 3. If 3 divides 9, the answer is 3. And if 3 divides 3, the answer is 1. So the factors of 72 are 2 multiplied by 2, multiplied by 2, multiplied by 3, multiplied by 3. And that can also be expressed as 2 raised to the power of 3 multiplied by 3 raised to the power of 2. And if you check 2 raised to the power of 3 and 3 raised to the power of 2, you see that the 2 is raised to the power of 3. And perfect cube definition is there are factors that their power are multiples of 3. So 2 raised to the power of 3 is a perfect cube, while 3 raised to the power of 2 is a perfect square, as we have earlier defined. Okay, alright, I haven't talked about this, so let's go to the questions and try to solve them. Now, the question number 1 is find the reciprocal of 2 over 3 all over 1 over 2 plus 1 over 3. So our first step is to start solving from the bottom. 1 over 2 plus 1 over 3. The LCM is 6. Now 6 divides by 2 is 3. 3 multiplied by 1 is 3. 6 divided by 3, the result is 2. Multiplied by 1, the result is 2. So plus 2. So we have 5 over 6. Alright, so we now have 2 over 3 all over 5 over 6, which is the same as 2 over 3 divided by 5 over 6. For us to be able to change this division sign to a multiplication sign, we have to invert this. So if we invert 5 over 6 to become 6 over 5, the division sign will become a multiplication sign. So let's do that. So we have 2 over 3 multiply by 6 over 5. If we multiply this to be 2 multiplied by 6, the result will be 12. And then 3 multiplied by 5, the result will be 15. If you divide the numerator, which is 12, by 3, you have 4. And if you divide the denominator 15 by 3, you have 5. So our answer will be 4 over 5. But don't forget, the question says find the reciprocal of. So it is the reciprocal we are looking for, and reciprocal is the inverse. So the reciprocal Reciprocal is 5/4, and this is our answer. So our answer is 5/4. The reciprocal is 5/4. But however, if the question was just simplify this, it would have just been 4/5. But we were not just asked to simplify, we were asked to look for the reciprocal. So the reciprocal is 5/4. Alright, please, if you have any question, drop it in the comment section. Alright, so the number 2 says, which of the following numbers is a perfect cube? We are not going to do this in this class. I'll leave this for you to try your hand, but I'll give you an hint. So each of them, use the long division to divide, and then look for which one all the factors are perfect cube. So thank you if you've watched up to this time. Thank you, and don't forget to share, comment, and do have a lovely time. Bye.